Today we're going to be going over total distance and total displacement. For total distance, the general equation is shown here, but more commonly it is seen as this. An integral from A to B of the absolute value of Vt times dt. Look at this example. Vt is equal to 5 cosine of t, where t is greater than or equal to 0 and less than and equal to 2 pi. The way you would set this up is the smaller of the two numbers, 0, would be your a. The larger of the two numbers, 2 pi, is going to be your b. Now we simply take our equation from right here and move it down right here and just put absolute value signs around it with a dt on the end. If you plug this into a graphing calculator, the answer will simply come out to be 20. Let's look at a graph of this. As you can see on the graph, the area shaded in red is the area that we're looking for. Area is always positive, so you don't consider this to be negative. All you have to do is find the area of each of these little sections and add them together. And that's it.
Calculating displacement. Displacement is the net change in position. The formula used to find displacement is the integral from a to b Vt times dt. In this example, we're finding the total displacement from 0 to c. There is a total of negative 28 units below the x-axis and 5 units above the x-axis. Therefore, negative 28 plus 5 is equal to negative 23 units. Negative 23 units is the total displacement for this graph. Example 2. The velocity is equal to 5 cosine of t from 0 to 2 pi. Step 1 is setting up the equation. We take the integral from 0 to 2 pi, 5 times the cosine of t dt. This equals 0. In order to find the integral, you can either plug it into the calculator or solve by hand. The third step is taking into account the initial condition, which is the s of 0 is equal to 3. Therefore, 3 minus displacement is still equal to 3, and therefore the total displacement is 0. The particle is still at 3.